Hi everyone, welcome back. We're on 1.3 Combining Transformations Part 2. So before we start, general transformation model y minus k equals a times f of b times x minus h, or if you isolate the k, if you isolate the y, it's y equals a times f of b times x minus h plus k, where a is your vertical stretch factor. So that is your vertical stretch about the x-axis. Okay, b is your b value, where if you do 1 over the absolute value b, that will represent your horizontal stretch factor, so your horizontal stretch about the y-axis. H value is your horizontal translation. Okay, horizontal translation, either uh, horizontal translation however many units left or right. Okay, and k is your vertical translation, however many units up or down. Okay, let's tie everything together. This should be example 1. Okay, example 1. The graph of the function y equals g of x represents a transformation of the graph of y equals f of x. So here's f of x, here's g of x. Okay, this is one of those problems, probably one of the most challenging problems is I give you two graphs, one original, one transformed. What are all the transformations that take place to get from the original graph to the transformed graph? Okay, challenging problem, but you can do it, definitely. Okay, describe a series of transformations required to transform the graph of f of x to the graph of g of x. Okay, so remember, I'm going to start with this because I can clearly see a reflection, right? One moment the quadratic here, the parabola is opening up, and then now it's opening down. So I know there's definitely a reflection going on. Remember, generally we said follow the order SRT. Think BEDMAS, do the multiplication, division first, then the additions or the subtractions. But we said SRT, you can start with the R, the reflection first, and then do the stretch, or you can do the stretch and the reflection. If you remember from that math lab, that stretches and reflections investigation, it doesn't change the final transformed graph if you do the reflection first or the stretch first. Okay, doesn't matter. Okay, so I'm going to start with the reflection. So number one, in let's pick green. Number one, okay, this is a reflection in the x-axis because reflection in the x-axis, therefore the a value is less than 0. Okay, I know that. So I'm going to take this f of x. Let's do the first reflection, the first transformation here. I'm going to pick this point and this point and reflect it down. So that's 1, 2, 1, 2, 3, 4. Let's plot those, and I'm going to do a dotted line. So that vertex is common as well. You do a dotted line because it's an intermediate transformation. It's not the final one. Okay? All right. That's number one. In blue, number two, if you look carefully, right, you might be tempted to say, well, Mr. Kim, look at this. Now that I have reflected it in the x-axis, well, I think it's just a transformation. This is a trap you might fall into. I'm like, oh, 1, 2, 3, 1, 2, 3, 4, oh, plus 3, minus 4, done, and then you write it up. Well, be careful, folks. I'm going to back up. Take a look. You got to be careful and take a look at your transform graph. Look at these points that they give you. It's subtle, but they give you these points for a reason. This is the vertex right here, vertex. Okay, that's the vertex. So you know what it corresponds to the vertex here. Okay, keep that in mind. So that's a good reference point to keep your eye on. But look at these 2 points that are given right here. Well, what do these do for you? This one and this one. So let's take a look at this. Look at the ratio of the movement of the x value to the movement of the y value, such as this. So this is what we're going to look at. So if you're suspecting already that, hey, I have some kind of stretch going on, let's see if it's a vertical or horizontal stretch. Okay. Okay. If I start here, let's think about this carefully. If I start here at the vertex as a reference point, okay, I'm going to also start here. Okay, let me do this one first on the green graph. I start at the vertex. I go 1, 2, so it's -2 over. And I go 1, 2, 3, 4, -4 down. Okay, so let's think of it this way. I'm looking at the stretch. I'm going from a -2 units and -4 units. Okay, this isn't the actual coordinate values. This is just movement in the negative or positive direction. So I have -2 units to the left, -4 units down. I'm thinking in relative terms here. Okay, somehow that movement corresponds to this movement. So start on this vertex. I know this is a common reference point that I could start at to see what my stretch might be. Okay, if I start here, let's go -2 units. Okay, and then if I go down, where will I hit? How many? So I go -2 units, so -2 units on the transform graph. Let's go down how many units until I hit a point, definitely hit a point on this graph. We can't say close enough exactly, right? So 1, 2, and you see this point right here. That's why there's a point right here. They're giving you a clue. -3, -3. Okay, so let me just rewrite this again. It's -2 units and -3 units on the transform graph. -2 units and -2 units is the same. Remember when the x value doesn't change, but the y value changes, what kind of stretch is that? That is a vertical stretch, folks. Okay? Because the y value is changing, the y value is changing. Okay? If I'm going from -4 to -3, think of it this way. -4 times blank equals -3. Sorry, equals -3. So if I off to the side, I can say -4 times x, what value equals -3? Well, divide both sides by -4, x equals 3/4. Okay, we know that. Okay, so I'm going to erase this back up. Okay, and I'm going to fill it in. So it's 3/4. So I multiply the 4 units, -4 units, by 3/4, and that will give me -3 units. Okay, so what does that 3/4 tell you? This is a vertical stretch about the x-axis. Vertical stretch about the x-axis by a factor of 3 by a factor of 3/4. Okay. Let's draw it up. So I'm going to clean this graph up. I'm going to back up, folks. I'm going to clean it up. And then let's show a vertical stretch of 3/4. So let me just clean this up. Okay, I'm going to back up. Let me restore my green graph here, my beautiful green graph. Okay. So 2 units left, 4 units down. That's the original, the green graph now, the reflected version of the original graph. Okay, the green graph. Now I need to go 2 units and 3 units. Okay, 1, 1, 2. So let me do this in blue. 1, 2, 1, 2, 3. It's subtle, but there is a difference. 1, 2, 1, 2, 3, right? It's slightly wider. And we expect that because it's a vertical stretch by a factor of 3/4. We expect that to make our parabola wider, right? And since it's 3/4, it's not a whole lot wider, but it is nonetheless still wider, okay? Okay, last part. Now we're going to start here, and we're going to look at the position of the vertex, pick a common reference point, and then all we got left is a translation. 1, 2, 3, 1, 2, 3, 4. So positive 3, that's my h value. Negative 4, since I'm going down, that's my k value. Horizontal, translation, 3 units right, vertical, translation, 4 units down. Okay, draw it in. Okay, let's continue. So these are all the transformations that are happening to take f of x and turn it into g of x. Let's extend our example here. State the equation of the transform function in the form y equals a times f of b times x minus h plus k. Okay. We said there's a reflection in x-axis. So a is less than 0. And we know that the vertical stretch factor the a value is 3/4. So a equals negative 3/4. Okay, let's bookmark that. Keep that aside. Negative 3/4. Okay. B is equal to 1. There's no horizontal stretch. H is positive 3 and K is negative 4. Okay. Here's our general transformation model, folks. Okay, from here up above. Y equals a times f of b times x minus h plus k. Let's substitute in our values. Y equals negative 3/4 f of b, which is 1, times x minus h, which is minus 3, plus k, which is minus 4. State the equation g of x if f of x equals x squared. So we're going from y equals x squared to y equals, okay, let's apply the transformations. A value is negative 3/4 times x minus the h value is 3, and we square it, and then we're translating down 4 units, or a vertical translation 4 units down. Okay. As a final check, you can do this on your own. Again, good idea to check when you're doing your diploma exam if you have time, right? I'm confident this is correct, but graph this on your graphing calculator. Graph this on your graphing calculator. See that it looks like the graph you did, but then test these specific points. Remember this point right here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, negative 7. So this is 5, negative 7. Okay? You can trace, you can do a trace function. So trace 5, negative 7 on your graphing calculator and see that it exists on that graph. Or you can plug in 5 and then work out the algebra, the arithmetic, and find negative 7. Okay? Example 3. Okay, different type of example where you are given a series of transformations, and then I ask you write a function that shows all the transformations put together. Okay, this will test your knowledge of, do I know where the transformations go? Do I know what's the a value, the b value? Do I know what the stretch factor is? Translations up, down. Okay, so let's take a look at this. Number 1. Let's go in order that they're listed. Okay, number 1, I have a horizontal stretch factor by a factor of 4. Okay. Horizontal stretch factor equal to 4. What does that mean? That means that's not my b value. Okay, be very careful, folks. 4 equals 1 over the absolute value of b. Okay, solve for b and you get your b value. Okay, be careful, right? So that is 4b equals 1, b equals 1/4. Okay, let's bookmark that. Keep that aside. B equals 1/4. 2, I got a vertical stretch by factor equal to 3. Vertical stretch about the x-axis by factor 3. What does that mean? That means straight up just a equals 3. What you see is what you get for the a value, okay? Just to be more specific, the absolute value of a equals 3. Okay, number 3. So we did the vertical stretch. Next one is a reflection in the y-axis. Reflect in y-axis. Well, when I do that, what happens? Okay, all x values. Okay, so remember we're flipping it or reflecting it about the y-axis. We multiply all x values by -1. So b is less than 0. Okay, we said b is 1/4, so we say -1 times 1/4. Therefore, b ends up equaling -1/4. Number 4. I have a translation. Okay. Horizontal translation. And it says 5 units left. 5 units left. Well, that's my h value. H, and it's going left. H equals -5. Vertical translation. Okay. 2 units up. Well, that's my k value, and that's +2. General transformation model, y equals, well, here's a small but important distinction. General transformation model, remember we can write it in 2 ways. If this is a written response question, I would be very accurate and particular. If they ask for it, I was going to write it like this with a k isolated on the other side, okay? But that's not what it's asking. You have to be diligent with the details here. Y minus k. They want it in that form, okay? So do as they ask. So y minus k equals a times f of b times x minus h. Let's fill in all the values. Y minus 2 equals an a value of 3, f of b value of -1/4 times x minus -5, which is x plus 5. Okay. Let's go to example 4. Next one. All right, this one. This is a challenging problem. I'll say right off the bat, this isn't something they would necessarily ask you on a diploma, but can you do this with the knowledge you have? Can you do this with the knowledge you have on combining all transformations? Yeah, absolutely. Okay, this is something that's within your abilities to do, but this is one of those painstaking, like very detailed problems. Okay, the graph of the function 4x squared minus 3x plus 2 is stretched vertically about the x-axis by a factor of 3, stretched horizontally about the y-axis by a factor of 1/2, and translated 5 units left and 7 units up. What's the new equation? Okay, um, I'm going to do this on a separate page. This is going to take a lot of room. Okay, let's do this. New page. Okay, this is example 4. Okay, I have the function y equals 4x squared minus 3x plus 2. I have a vertical stretch where a equals 3. Okay, 2. I have a horizontal stretch where the factor is 1/2. So what's my b value? 1/2 equals 1 over the absolute value of b. So b must equal 2. So I'm going to circle that, circle that. 3. Translation. 5 units left, 7 units up. So h equals -5, k equals 7. Okay. In function notation, so I'm going to start with the general transformation model, a times f of b times x minus h plus k. If I substitute all the values in, that's y equals 3 times f of b, which is 2 times x minus -5 is plus 5, and then plus k, which is plus 7. Okay. This is in general. That's not what we're asking. We're asking, what is the new equation? I need a new equation. This is in function notation. I want an actual equation with x's and y's. No more function notation. This is where it gets challenging with the substitutions, keeping track of them. And then the expansion is another place where there are lots of landmines where we can go wrong if you don't do the expansion correctly. This is a challenging one because of that. Okay, so let's do this. I'm going to start with y equals 4x squared minus 3x plus 2. Okay, so 1, I'm going to apply a vertical stretch where a equals 3. So what does that look like? That's y equals 3. Remember, we're stretching the entire function vertically. So I'm going to multiply the entire thing by 3. Okay, let me just move that over. Okay, good so far? All right, stay with me here. 2. Horizontal stretch. Let's do this one by one. Horizontal stretch. Where b equals 2. Okay, where's that b value? Right here, right? Let me color code this. A value, A value, A value, B value, B value. Okay, let me write the B value. You can give it a try. Pause it here, write it, see if you can put it where it is. So B value, right, is 2. Okay, and that's going to go on all the x's, right? So what does this look like? Y equals 3 times 4. Okay, 2x squared minus 3 times 2x plus 2. Okay, with me so far? number 3. Okay. Translate 5 units left. Okay, what does that look like? We're going to translate 5 units left. Y equals 3 times 4 times 2 times, right? The x value is the x value is the part getting the translation, not the 2x, right? So 2 times x plus 5, and then we need to square that. Okay, so this is where it gets a little bulky here. So 3 times in square brackets 4 times 2 times x plus 5, and then remember that entire thing gets squared. I need to put another set of round brackets. Okay, minus 3 times, same thing, 2 times x plus 5. Okay, another horizontal translation, and then plus 2. Oops. Okay, and then let's do the last translation. So translate 7 units up. Okay, translate 7 units up. Y equals 3 times 4 times 2 times x plus 5 squared minus 3 times 2 times x plus 5 plus 2. Where am I putting the 7? Let's take a look. Where am I putting that 7? Look where this k is. It's outside of everything here with the function, right? So it's right here. I'm putting the 7. So look at where you're going to put the 7. Plus 7. Okay. Okay, let's color code this thing again. So 3 here, 2 here, 2 here, 5 here, 5 here, and then 7 here. Okay? Thought you were done, huh? No. Simplify, right? Good practice is to simplify where possible. Expand and simplify. Oh man. Okay. Let's do it. Y equals 3 times 4. Here, let's do this. I'm gonna not rewrite it again. Y equals, I'm going to expand by squaring this, right? Squaring that this way. So let's do it one by one. I'm not going to skip steps here. 3 times 4 times 4 x plus 5 squared. Okay. Minus 6 times x plus 5 plus 2 plus 7. Okay. Let's keep working on the inside. So 3 in square bracket, 3 times the square brackets. Let's do 4 times 4. Okay, that's 16. X plus 5 squared minus 6 times x plus 5 plus 2 plus 7. Okay, y equals, let me distribute that 3 across the square brackets. That's 48 x plus 5 squared minus 18 x plus 5 plus 2 plus 7. Y equals, okay, oh, you know what? Yeah, oh, I missed this. Ooh. So 3 times 2 is 6, and then plus 7. Okay, so I have y equals 48 times x plus 5 squared minus 18 times x plus 5 plus 6 plus 7. Let's add those two before we expand. So I have this minus this plus 13. Now let's expand these. The binomial here equals 48 times x squared plus 10x plus 25 minus 18x minus 90 plus 13. Y equals 48 x squared plus 480 x plus 1200 minus 18x minus 90 plus 13. Y equals 48 x squared plus 462 x plus 1123. Wow. That's a big one. Okay. Challenging. Again, beyond what you would need to know for the test and the diploma, but certainly challenging enough if you really want to give it a try. This is similar to the textbook problem. So in the textbook, very similar to page 42, number 17. Okay, so if you want to give it a try, give it a go, and good luck on it. Okay? All right. See ya.